The immune system is the body's intricate defense network, responsible for protecting us from harmful invaders, like bacteria, viruses, fungi, and other pathogens. It's a highly complex system made up of various cells, tissues, and organs that work in harmony to detect and eliminate foreign threats, maintaining a state of homeostasis, or balance, in the body. Key components of the immune system. White blood cells, leukocytes. These are the primary defenders of the immune system. They circulate in the blood and can quickly respond to infections. There are several types, including macrophages, engulf and digest pathogens in a process called phagocytosis. Neutrophils rapidly respond to infection, forming the body's first line of defense. Lymphocytes includes B cells and T cells, which are crucial for adaptive immunity, targeted defense against specific pathogens. Organs and tissues. Bone marrow. The origin of all immune cells, producing stem cells that differentiate into various types of immune cells. Thymus, where T cells mature and learn to distinguish between the body's own cells and foreign cells. Spleen filters the blood, removing old or damaged cells and helping to detect infections. Lymph nodes, small bean-shaped structures distributed throughout the body that trap pathogens and provide a meeting ground for immune cells to coordinate their attack. Two main branches of immunity. Innate immunity, the first line of defense consisting of barriers and general responses that work immediately against any invader. Physical barriers. Skin, mucous membranes, and cilia in the respiratory tract prevent pathogens from entering the body. Chemical barriers. Enzymes in saliva, stomach acid, and other antimicrobial substances neutralize threats. Cellular defenses. Cells like neutrophils and macrophages patrol for intruders and can quickly respond to infections through inflammation, a process that recruits more immune cells to the site of infection. Adaptive immunity, a specialized response that develops after exposure to a specific pathogen. It has a memory and can recognize and respond more effectively if the same pathogen returns. Faux cells produce antibodies, which are proteins that bind to specific antigens, foreign substances, on pathogens. This binding neutralizes the pathogen and marks it for destruction. T cells have different roles, including killing infected cells, cytotoxic T cells, and coordinating the immune response. Helper T cells. Immune system vocabulary. Antigen, a substance that triggers an immune response, often a protein on the surface of a pathogen. Antibody, a protein produced by B cells that binds to specific antigens to neutralize or mark pathogens for destruction. Pathogen, an organism or agent that causes disease, such as bacteria, viruses, fungi, or parasites. Inflammation, a localized response to injury or infection, characterized by redness, swelling, heat, and pain, aimed at removing harmful stimuli and starting the healing process. Phagocytosis, the process by which cells like macrophages engulf and digest pathogens. Cytokines, signaling molecules that help coordinate the immune response, recruiting immune cells to infection sites and regulating inflammation. Immunological memory, the adaptive immune system's ability to remember a pathogen after initial exposure, allowing for a faster, more effective response if it reappears. Examples of the immune system in action. Common cold. When a virus like the rhinovirus enters the respiratory tract, it's met by barriers in the nose and throat, like mucus and cilia. If it bypasses these, the innate immune cells, like macrophages and neutrophils, try to destroy it. If the virus persists, the adaptive immune system creates antibodies that specifically target the virus, clearing the infection over time. Innate immune responses. Sneezing, watery eyes, vomiting, and diarrhea are innate responses to expel pathogens. Inflammation occurs when immune cells release substances that widen blood vessels, causing redness and swelling at infection sites. Adaptive immune responses. When exposed to pathogens, B and T lymphocytes create antibodies in memory cells. This allows for quicker and more effective responses to future infections by the same pathogen, such as immunity developed after chickenpox or vaccination. Allergic reactions. Sometimes, the immune system mistakenly identifies a harmless substance, like pollen, as a threat. This leads to an overactive immune response, where immune cells release histamines and other chemicals, causing symptoms like sneezing, itching, and swelling. Autoimmune disorders. Conditions like lupus or rheumatoid arthritis occur when the immune system mistakenly attacks the body's own cells, perceiving them as threats. This can lead to chronic inflammation and tissue damage.